Oh, hey, what's up, everyone? We're going to continue our journey through sketching reciprocal functions. So, this time out, it's basically the same situation, except the graph looks different. This one is a parabola. So, really, they're all done using the same method. It really doesn't matter what type of function that you're given. Okay, you would basically just find all of the points by getting random y values and then getting the reciprocals of them. Okay, so away we go, right? We're gonna work on this particular question right here, and this is just a second example, not really that different than the linear, and you're only going to be working with linear and quadratic anyway. So why don't we take a look at doing this one right here? Oh, excuse me. Coughing on YouTube videos. That's cool. We're not going to edit. We're just going to keep going. You're getting the real life experience here. Let's do this. Okay, so first of all, you can start with any point on this graph. It doesn't matter where you start. Me personally, what I like to start with are the x-intercepts. So notice that the two x-intercepts that you have, anytime you have an x-intercept, the y-coordinate is 0. And remember what we said, okay, you cannot get the reciprocal of a 0. The reciprocal of 0 is undefined. So what we can do is we can replace these with vertical asymptotes. So let's do that first. That's what I like to do as my first step. Okay, now it doesn't really say to label what the what the vertical asymptotes are. Of course, all vertical asymptotes are written as x equals something. And in this particular case, you can see that this one is x is equal to 2. And this one is x is equal to negative 4. So again, all right, this is a great way of starting your reciprocal function graphs, is to look at the x-intercepts. If there are any, there usually is at least one. Okay, if it's linear, there's one. With parabolas, there's usually two. There are exceptions. But in this case right here, okay, we definitely have two x-intercepts, and I changed them to vertical asymptotes because the y-coordinate on those points are 0. The reciprocal of 0 is undefined, so the graph cannot cross the vertical asymptotes. Okay, so that's a good place to start. Now, another thing that I like to start with after doing the vertical asymptotes are the invariant points, which I will abbreviate as IPs. Invariant points are the points where y is equal to 1 and y is equal to negative 1. Okay, so as a general rule, okay, those are always going to be your invariant points. The x-coordinates are going to be different each time, depending on the graph. But those are the y values because remember what we said in the previous videos. We said that the reciprocal of 1 is 1, reciprocal of negative 1 is negative 1. Those are the only two number values where the reciprocal is the same as the original. So those will always be the y-coordinates for the invariant points. And in this particular example, we have 2 of each. Okay, you can see on the graph that there are 2 points on the graph where the y-coordinate is equal to 1. And there are also 2 points on the graph where the y-coordinate is equal to negative 1. So those points will be the same as the reciprocal points. Everything else is going to be different. So you can, at this point, start taking random values and just random points on the graph and try to get the reciprocal of them. Like, for example, say I chose this point right here on the graph. Okay, that has a y value of positive 4. The reciprocal of positive 4 is 1 over 4, which is approximately 0.25. So I do not move left or right. I just move down to what I think is approximately 0.25. Okay, that's just an approximation, and so on. Okay, you can keep doing some more points like that. So for example, we have this point right here, the y-intercept is negative 8. The reciprocal of negative 8 is negative 1 over 8, which is approximately negative 0.0125. So what I do is I take this negative 8 point on the y-intercept and I move it up to what I think is approximately, and I don't know what happened here. Okay, we're in business. Approximately right here. Same thing with this vertex of negative 9. The reciprocal of that is negative 1 over 9, which is 0.111. Just going to approximate it right here. And then when you get a few more points, you'll notice that this goes something like this right here. And then this graph goes like this as you go through the points. And I didn't touch on this little left wing up here, okay, but you can just take points like, say, for example, this is a 5. The reciprocal is negative 1 over 5, which is down here somewhere. And you can fill in a few more points to flesh it out, but you get something like this. So basically, if it's a parabola with two x-intercepts, your new reciprocal function will come in 3 different pieces. Okay, because the two x-intercepts give you 2 vertical asymptotes, which splits your graph up into 3 sections. Now, there's also a horizontal asymptote here at y equals 0. That's pretty much always going to be your horizontal asymptote, all right, for all of these. So we don't really actually need to think about that too much, but the vertical asymptotes will always be different. So just a few other things here. You notice I've written the IPs, the inflection points, always with a y value of 1 and negative 1. How do we get those x values that are going to be different each time? We're going to figure that out in another video, and that's going to be strictly algebra. Okay, so we're just going to plug in numbers for y and solve for x. You're going to see that on a separate video. And then also we need to take a look at domain and range. So we'll do that on a separate video as well. One thing I do want to point out before we leave is if we take a look at Desmos, okay, notice that I've graphed this. This is what you had in your video right here. This is just a random parabola. I have the equation right here. If you have the equation, then you can graph the reciprocal of this. And you could put in 1 over x squared plus 2x minus 8, and that works. Personally, okay, I like to save a little time. Here's what I do. I just call this f of x. And then what I do is in my second equation here, I just write y is equal to 1 over f of x. And notice here, okay, the graph in blue gives us the reciprocal. And you can see here, okay, the Desmos doesn't automatically draw the asymptotes in for you. Although you can see at negative 4, okay, you can see that there would be a vertical asymptote there, because the graph does not cross that vertical line at x is equal to negative 4. And then you can also see at x is equal to positive 2, there should be a vertical asymptote there. You can put them in the equation bar, but you can notice right here, they actually, if you click on the points, the invariant points, they give you the x values on here. We haven't learned how to calculate these yet, but it's not too difficult. It's just algebra. And you notice here, okay, we have 2 points where y is equal to 1, and another 2 points where y is equal to negative 1. Those are the only points where the original graph and the new reciprocal graph will intersect. And you can see that right there.